All right, let's dive into something that's frankly a game changer for anyone building modern apps. Swift's async/await. This isn't just a minor update. It completely transforms how we handle background tasks, making our code so much cleaner, safer, and, actually readable. So, let's get into it.
So tell me if this scene feels familiar. You're trying to fetch some data, maybe process a file, and your code starts drifting to the right. You get this pyramid of curly braces, this deep, nested mess where every single step depends on the one before it. It's a huge pain, right? For the longest time, that was just how we had to do things.
And yeah, this nightmare has a name. We call it callback hell. It's that place where a tiny bug takes you hours to find because you're tracing logic through 5 different levels of indentation. And trying to handle an error that happens way down in that nest, forget about it. It's a mess.
Okay, so to really appreciate just how amazing the new way is, we have to take a quick trip back in time. Let's look at the old way, the world of asynchronous code before async await came to the rescue.
So the classic method used what we call completion handlers, or callbacks. You'd pass a chunk of code, a closure, into a function, and it would run whenever the task finished. But what if you needed to do 3 things in a row? Well, you'd nest one callback inside another and then another inside that. Your code starts reading sideways, and trying to pass an error all the way back up that chain, oof, that was a recipe for disaster.
But thankfully, things have changed. Swift gave us a truly modern solution. See, async/await isn't just some new syntax. It's a completely different way of thinking about code that runs in the background. It's our ticket out of callback hell.
Now, this sentence right here, this is everything. This is the core promise of async await. I mean, just imagine writing code that fetches something from a server, but it reads just as simply as code that adds 2 plus 2. Straight line, top to bottom. That's the magic we're talking about.
So how does it all work? Well, it starts with this little keyword, async. When you slap async on a function, you're basically telling Swift, hey, just a heads up, this function might need to pause for a bit to wait for something. And here's the crucial part. While it's paused, it doesn't freeze your whole app. Your UI stays perfectly responsive.
And this is its partner in crime, await. You stick await in front of any call to an async function, and that's the exact spot where your code hits the pause button. It basically says, okay, I'm going to chill right here until I get a value back from this async call. Once I have it, I'll pick up right where I left off.
And this chart just lays it all out perfectly. I mean, look at the difference. On the left, you've got the tangled web of completion handlers. And on the right, the clean, straight line, easy-to-read world of async await. And error handling, it goes from that complicated mess to a simple do-catch block that we all know and love. It's night and day.
Okay, theory is one thing, but seeing it in actual code is what really makes it click. So let's take a look at what this really looks like in practice. So here we have a function signature. Notice those 2 keywords there. We've got async, which we just talked about. It means the function can be paused. And then we have throws, which tells us it might fail and throw an error. This combo is it's incredibly powerful for dealing with background tasks that might not work out.
Now, inside that function, you'd see a line just like this one. That try await part, that's the magic. The code literally pauses right there, lets the system go do other things so the app doesn't freeze, and just waits for the network to get back to it. As soon as that data arrives, boom, the function wakes up and continues on the very next line.
So you might be wondering, how do I kick this all off from my normal synchronous code like in a button press? Well, you wrap it in a task. A task basically creates a little asynchronous bubble where you can call your fetchUserData function. Then inside that task, you just use await to wait for the result. Simple as that.
And what about when things go wrong? The network connection drops or something. This is where it gets beautiful. Because our function throws, the error doesn't get lost in some deep, dark callback. Nope, it gets thrown, and we can catch it cleanly with a standard do-catch block. It's straightforward, it's reliable, just like synchronous code.
So we've seen the what and the how. Now let's just really hammer home the why. Let's break down the 3 biggest wins you get when you start using async/await.
So, number 1, you get a beautiful linear code flow. 2, you get way better error handling. And 3, you get this super powerful safety net called structured concurrency. Let's dig into each one real quick.
First up, linear flow. Look, your brain is wired to read things top to bottom, like a book. With async/await, your code finally follows that same natural flow.
This makes it so much easier to understand at a glance and way easier to come back to and maintain 6 months from now. The second win is all about error handling. Like we saw, you get to use the exact same try-catch pattern you already use everywhere else. This is a massive quality of life improvement. No more trying to pass error objects through 10 layers of callbacks. The code that can fail lives right next to the code that handles the failure.
And this third one, this is the real game changer, structured concurrency. Basically, it means Swift understands the relationships between your tasks. So, imagine you start one big task to load a user's profile. That task might kick off 3 smaller tasks to download their picture, their posts, and their friends. But what if the user navigates away? Well, when the main task gets canceled, Swift is smart enough to automatically cancel all 3 of those child tasks. This is huge. It stops your app from doing pointless work, it saves battery, and it prevents all sorts of nasty bugs. It's like an automatic cleanup crew for your code.
So, let's pull all this together. Why does this actually matter? What's the big picture takeaway for you as a developer?
If you remember anything, remember this. Async functions keep your app feeling snappy and responsive. Await only pauses one specific piece of work, not your entire app. And when you put those two together, the code you write is just better. It's cleaner, it's safer from all those classic concurrency bugs, and it's so much easier for your whole team to work with. When you get right down to it, learning async/await isn't just about picking up some new syntax. It's about adopting a whole new mindset that lets you build bigger, more reliable, and more scalable apps with a lot less headache. It really is a major step forward for all of us.
And that pretty much wraps it up. So I'll just leave you with this question to think about. As you look at your own projects, what's the first piece of messy callback-style code that you could refactor to use the clean, simple power of async await? Thanks for tuning in.